All right, so in this video, we're actually going to do two very important things. The first thing is we're going to have a conversation about what do different market structures generally mean for market outcomes, at least from a theoretical perspective. And we're also going to dig into a little bit of the math behind some of these theoretical outcomes. So why do economists tend to think the way that they do about particular market structures? And like all economic models, the reason why economists tend to feel the way that they do is because the models tell us how to feel in many circumstances. And so in this video, we'll sort of overview and review to some extent different market structures, sort of what we expect out of them. And then we'll sit down and do the math, talk about the math a little bit, and sort of, you know, how the math is useful to us in this particular circumstance, not simply from the ability for us to calculate particular outcomes, but also for us to look at what within the math, within the structural components of these economic models that we're going to be discussing, what are those changes that could be made within the model to affect the outcomes. And so that'll make a little bit more sense here in just a few moments. So the typical way for us to think about market structures as economists is to think about them in terms of their competitiveness. How competitive are markets? And the reason that we do this is a lot to do with the sort of traditional economic model in economics, which suggests that competitive outcomes are what's best for society. That if society could, in a sense, choose the type of market structure that it enjoys, that it would choose a competitive economic market because competitive economic markets are so called efficient. And so that's one of the main reasons why we still tend to think about markets in terms of their competitiveness, because we still tend to believe that there's some truth to the idea that a more competitive market means a more efficient market. And then if we have more efficient markets, we have a more efficient economic system as a result. Now, beyond economic efficiency, of course, there are other concerns that we may care about, issues related to equity and discrimination that may exist even in an economic system which we might readily describe as economically efficient. And we can maybe cast those conversations within the scope of social efficiency, where we may consider the negative social effects of some market outcomes, which we're going to do here as well within the context of competitiveness. But in 2024, it's certainly true that economists are a little bit less tied to the basic idea that competitive markets are always efficient. That there are certain circumstances where even if you have competitive markets and even if you have economic efficiency, there may be reasons for us to be concerned or perhaps even unhappy with that particular market outcome. But we're going to stay in kind of the traditional theoretical bounds here, where we're going to ignore things like negative and positive externalities, and we're going to ignore issues related to public goods and so on and so forth. And so we're going to stick with just sort of the traditional market conversation. We're interested in sort of two things. One is how are firm level choices made within the context of the market structure? In other words, how does the different market structure affect firm level choices? And then once we feel like we have a good handle on what's going on at the firm level, we can then aggregate those decisions to the market and look at the market outcomes. Now, of course, in the case of a monopoly, a single firm monopoly, the firm level decision becomes the market decision. But we're going to look ultimately at several different types of market structures, and the distinction between how our individual level choices made and then what they mean for the broader market outcome is still significant regardless of whether we're talking about a competitive market or a monopolistic market, or a duopolistic market, which is what we're going to focus on in a little bit later. So from the sort of structural perspective, we will consider some particular characteristics of markets. So how difficult is entry into the market? How much information is known? How similar are the same goods for different firms? And how many buyers and sellers are there in the market? And the way that I've always thought about it is each of these is a dial, and they can be increased. So you can increase the difficulty of getting into a market. You can increase the amount of information available. You can increase the distinction between goods, or the similarity between goods rather. You can increase the number of buyers, or the number of sellers, and that's going to affect first and foremost how we define that particular market structure, what we actually call it. Um, and but then of course more importantly it's going to define in some ways how the market structure affects society, or ultimately produces the outcomes which affect society. And we tend to think about sort of four basic types of markets. There's competitive markets, there's monopolies, there's oligopolies, and then there's monopolistically competitive markets. And for this particular lecture, we're going to focus on the first three: competitive markets, a monopoly, and then an oligopoly example. That's not because monopolistic competition is not important. In fact, it's in many ways one of the more important types of market structures um, that we've added to sort of our arsenal of different market structures. So, monopolistic competition kind of came a little bit later in terms of the sort of history of economic thought. And as is the case in a lot of science, including economics, new ideas serve to fill in the gaps that were left by old ideas. And monopolistic competition sort of represented a type of market structure probably that people could see, but they didn't see necessarily represented within economics textbooks. And so it's a very important market structure, and we'll come back and we'll talk a little bit more about monopolistic competition a little bit later. So you know, we can think about each of these different market structures in terms of those previous sort of characteristics. And so, competitive markets are easy to get into, information is known, the goods are basically the same, and there are many buyers and sellers. Now, what that ultimately means for us is actually very profound, because what competition does to a market theoretically is it removes the price setting power of firms within that market, or price affecting power, if you will, of firms in that particular market. In perfectly competitive markets, we actually make the assumption that firms are what we call price takers. So the market sets the price, and then the firms respond by selling their goods at that particular price. I talked about that in the previous video on perfect competitors. So we call perfect competitors price takers. And in the case of competitive markets, and in the case of monopolies and some types of oligopolistic markets, firms are able to set or affect the price. And so in monopoly situations, we have a single firm that is a price taker, maker rather. They actually create the price that they sell their good at. Now, that's always a little bit of a misunderstanding for students. When you say that a monopoly is a price maker, oftentimes that conjures up an idea that the monopolist is able to charge whatever they want. In fact, as we'll talk about, the monopolist is constrained by how much they can charge, which is true of any market because the demand curve constrains what firms are able to charge um, their consumers, because at a certain point the willingness to pay drops to zero. And I'm sorry, the willingness to pay is sort of exceeded in the context of a particular demand curve. And so a monopolist may charge a price, but nobody may be willing to pay for it, and so that monopolist is not going to sell anything. So they may be a monopoly, but so now, of course, if we're talking about certain types of goods that are seen as like necessity goods, so like electricity. There's a reason why we regulate electricity markets. There's a reason why we regulate water markets, because those goods are goods that we can sort of see are potentially exploitable. And that's a big concern under monopoly situations. And so, under various types of sort of exploitation, we might regulate a monopoly, and we very often, of course, do that. And then in oligopolistic markets, and in particular, the one that we're going to discuss mathematically here in just a moment, uh, the firms don't have complete price setting power, but they affect the price. And in a very direct way. And we'll talk about why that is in just a moment. But so in competitive markets, firms are price takers. In monopolies, the firm is a price maker, and then in oligopolistic markets, firms have some price affecting power. They are able to affect the price, maybe not necessarily set or make a price, as in the case of a monopoly, but can affect it. And when we look at the differences between oligopolies and monopolies, we see that there's some similarities. They're both fairly difficult to enter. Information is a little bit less known. The goods are have distinction. Obviously, the monopolist is the only one that sells a good. Whereas in oligopoly markets, the firms are selling the same good, but those same goods may be distinct as opposed to the competitive market. And then, really, the most important feature of oligopolies is it's a small number of firms, a small number of sellers. We're actually going to talk about a particular type of oligopoly called a duopoly, which is a market with just two firms in it. Um, but of course, what do these market structures mean for society? And again, that's why we're here. We're gonna go through the math, and the math is actually really going to be what tells us what we theoretically can expect from these particular markets. Now, real quick, we're going to consider a particular type of duopoly, which again is a type of oligopoly. There are three types of duopolies. There's Cournot, that's going to be the one that we consider, and then there's Bertrand and Stackelberg. These will be things that we discuss um, a little bit later. So we'll have conversations about these, and I'll probably even maybe mention a little bit about them within this particular video. But we'll talk more at length about them. But we're gonna focus our efforts on this particular lecture on the Cournot type of oligopoly or duopoly, and I'll explain what that means in just a moment. Okay, so again, the first thing we're going to consider is how are firm level choices made, and then what does that mean for the market outcomes? So let's get into that. So again, these are going to be the three types of market structures that we consider here: competitive firms, a monopoly, and then a duopoly. And then again, specifically Cournot. So in a competitive market, the firms are maximizing, a pretty straightforward um, profit function, P star times Q sub I. Q sub I just means that this is an individual firm within the market. So there's like Q1, Q2, Q3. We're just going to index those by QI to keep things general. And so this is the profit function. This is total revenue. P star times QI. That's the total revenue the firm would make. And then, of course, minus cost. where cost is some function of their production level, QI. And you'll notice that in the competitive markets, the choice variable to optimize is just production. So each firm is choosing an amount to produce. And the reason why that is because we assume that competitive firms are price takers. And therefore, the only choice that they have to make is how much do they produce. We of course have talked about this previously, and so if that is a little murky for you, I would encourage you to go back and watch the last video I made on perfect competition, and we talk about why firms are price takers and kind of what that means. In short, what it means is that it means that the market price ends up being the marginal revenue for the firm. And so when we apply the classic profit maximizing rule of marginal revenue equaling marginal cost, which you're going to see a lot here in just a few moments, then we get the market price is equal to marginal cost for competitive firms. That's the classic marginal cost pricing. That's what makes competitive markets efficient. Is in fact that the prices that are charged in them equal the marginal costs for the firms at their optimal levels of production. Basically, what that means is the price reflects the cost of production, essentially. And so you're paying for what it costs to produce that particular unit. That's economically efficient. It's kind of like a closed loop, if you think about it that way. And so each firm has a profit maximizing choice, QI star, and then the market quantity, Q star, big Q star. It's just, of course, going to be a summation of all the individual profit maximizing decisions. This is another reason why we consider competitive markets to be efficient, is because here the profit maximizing choice works in favor of society because firms are not able to pick prices. So ultimately, what that means is that firms end up competing over their ability to produce, which ends up being about the production function as well as the cost structure of the firm. And if firms are improving their production function and lowering their cost structures as a means to produce more quantity, then that's good for society because it means that things will get cheaper over time and production functions become more efficient. And so that's why we think about competitive markets as being economically efficient. Firms choose optimal production with respect to market price and their cost structure. And that ends up sort of leading to um, economic efficiency. So let's go through that example mathematically, which I have right here. And so this is a very ends up being just a very basic supply and demand example, because what ends up happening under competitive markets is that because our assumption is that firms all maximize profits the same way, which is they produce at a level where marginal revenue is equal to marginal cost. And again, we assume, especially if we think about things in terms of the long run, um, then we assume that marginal costs converge. What that means is that when we take a competitive market into the long run, the cost structures of the firms end up looking identical. And so the marginal costs all end up being identical. Basically, you can think about over the long run, the competitive market is going to create many sellers that are all the most cost efficient. So they're going to have the lowest marginal cost, and their marginal costs are all going to equal each other. That's actually one of the main features of competitive markets, is that in the long run, the marginal cost of each firm equals each other. What that also means is that the profit maximizing level of production is equal across all firms. So they actually, each firm produces the same number of goods in the long run. That's the theoretical sort of setup there, which, that's maybe a hard story to take. When you think about it in terms of the real world, the competitive forces always lead to these efficient outcomes. It's sort of hard to maybe believe, but what has traditionally happened in, say, the like U.S. economy is that you've had competition, and then oftentimes firms have been able to acquire market power over time, which effectively makes those markets less competitive over time. So it's, in a sense, we've not seen many or any at all of like what a perfectly competitive market would actually look like. Again, this is a theoretical sort of construct. We want to make sure that we understand that from the outset. But what the competitive model shows us is what would happen if we had perfect competition. What would happen if we had a bunch of maximally efficient firms with identical marginal cost all producing the same level of production? What would happen? What would that look like? And so this is what it would look like. So in these examples, we're going to assume kind of the most basic demand structure, and then we're going to take you through a specific numerical example. So the most basic demand structure is just that market price is equal to, and then this is just a function of Q, A minus BQ. Where sort of graphically, if we do this in classic PQ space, A is just the demand curve's vertical intercept, and then B, of course, is the slope of the demand curve, just to put this in the context. And then because it's a competitive market, the market price ends up equaling marginal cost. So we have marginal cost pricing. So we're sort of imposing that particular condition on the market. Now, in this particular circumstance, we're taking that kind of to an extreme, and we're saying that the supply curve is in fact horizontal. Um, we do this mainly for mathematical reasons so that we can compare the monopoly and the duopoly. And sometimes students will see a horizontal supply curve, and it's a little, you're so used to the normal upward sloping supply curves that it can be a little bit confusing. It's really the basic idea that we're going with here is that because we have marginal cost pricing in competitive markets, and because in essence the supply curve is marginal cost, we're just going to say that that price that what ends up becoming market price is we're going to sort of think about it in terms of a static scenario. So it's there is a market price P that also defines the marginal cost as well, and so that's why the supply curve is horizontal. We can still think about this as a normal supply curve. It does end up kind of having some unique features, but it's a horizontal supply curve, and you'll see why we did it probably when we get to the other type of market structures. So in order to figure out what the outcome of this market is, or the outcome of a market. So in this particular scenario, this is our demand curve, and then our supply again is just going to be defined by the marginal cost. So we have a demand, which is P equals 100 minus 2Q, and then we have supply or just marginal cost equal to $20. There should be a dollar sign right there because that is an amount of money. Oops. There we go. All right. I'm not sure why that took so long. Anyway, so again, the marginal cost is $20. In order to find Q star, we just simply set demand equal to supply and solve for Q. And so when we do that, you can see that we get a Q star equal to 40. And in order to find P star, we just plug that back in. Normally, that's what we do. Here, we already know what P star is. We know P star. We knew from the outset that P star was going to end up being 20, but you can plug it in just to give yourself a little bit of confidence there. And so we have a market equilibrium outcome of Q star being 40 units. That's for the entire market, and the market price being $20. Um, we can then go ahead and calculate consumer and producer surplus here, because we know what all the values of all these things are. We know A, for example, is 100, and we know that P is 20, and we know that Q star is 40. So we can do the calculation here. So consumer surplus is just going to be the area of this triangle, and that's going to be 1/2 base of 40 because Q star is 40, so a base of 40, and then a height of 80 because P is 20, A is 100, and so the vertical distance here is 80, 100 minus 20. And so when you do the math here, we get consumer surplus of 1600. Now you'll notice that there is no producer surplus here, which actually is the theoretical long run outcome of a competitive market. Right? We have the zero profit condition of competitive markets, and because of that zero profit condition over the long run, that essentially means that producer surplus goes to zero as well. And so the fact that we have producer surplus equal to zero here again may seem weird because you're typically used to seeing values for producer surplus. But the reason that producer surplus is zero here is because we have a horizontal supply curve. And so, again, the horizontal supply curve reflects the price taking behavior of firms in the market. And so, the producer surplus being zero here is actually a nice reflection of competitive markets. And then, if we look at total economic surplus, that's just going to be consumer surplus plus producer surplus. That's sort of the overall health of the market. We can see that it's 1600. We're going to compare these numbers to the outcomes we see in the other types of market structures here in just a moment. So we'll look at consumer surplus, producer surplus, and then total economic surplus. And again, that's going to help us to understand the different market structures and the outcomes. So again, if this market, and when I say this market, I mean a market that has a demand curve that is P equals 100 minus 2Q, and for a market with a supply curve that is P is equal to $20, then the outcome is Q star is 40 units and P star is $20 with a consumer surplus of $1,600 at those particular values. Now, if we go and we look at the monopolist from the perspective of the producer's problem, which we saw before with the profit maximization of a competitive market, things are a little bit different. In particular, what's different for the monopolist is that the price the monopolist charges, because remember, the monopolist is a price maker, they set their own price, is going to be a function of how much they produce. So, what the monopolist charges is going to be a function of what the monopolist produces. So, this says the monopolist price, which is a function of the monopolist quantity, times the monopolist quantity. So, that's the total revenue, and then of course the cost, which is a function of how much the monopolist produces. And so here the monopolist has two choice variables. They choose not only how much they produce, but they also choose what they should charge for it. But the actual choice here is actually pretty straightforward. Now, what this ends up meaning is that the monopolist price, which is the monopolist marginal revenue, is going to be a function of quantity. So marginal revenue is not static in the way that it is for the competitive firms, and we'll see this graphically in just a moment. The result of this is that the monopolist price ends up being greater than the marginal cost of the monopolist, and as a result, as well, the monopolist quantity is less than the competitive market outcome. So you get less product and you pay a higher price for it under the monopoly. It's kind of the classic monopolist outcome. So the firm chooses optimal production with respect to market demand and their cost structure. And then to come back to the second choice variable, the price, then they just charge what consumers are willing to pay. So the monopolist finds a profit maximizing quantity for themselves and then ask themselves what are people willing to pay for that level of production, and then the monopolist charges them their maximum willingness to pay, which is going to be a pretty straightforward thing to do in just a moment. So let's hop right back in to the math here. It's a little bit slow because the whiteboard files are big this time around because there's a lot of math on this one especially, so it's just a little slow, but we'll get it there. Okay. had a lot of fun making these. Kind of took me back to when I was learning this stuff. Okay, so for the monopoly outcome, so here we have graphically the classic sort of monopoly story. Again, like I said, marginal revenue to the monopolist is not static the way it is to the perfect competitor because the monopolist has price setting power. And so the marginal revenue is a function of quantity. Interestingly enough, if you do the math, what you end up getting is that the marginal revenue curve to the monopolist is just the demand curve with twice the slope, which I'll show you in just a moment, that we actually derive it over here that way. But you can always just remember that as well, that the marginal revenue curve is always just the demand curve with twice the slope for the monopolist. So you can see we get that steeper curve here. The monopolist maximizes profits by setting marginal cost C to marginal revenue. That produces profit maximizing quantity for the monopolist. And then the monopolist is going to take that up to the demand curve and charge consumers that maximum willingness to pay. So what we've got to do is we've got to figure out what's profit maximizing quantity for the monopolist, and the way that we're going to do that is we're going to set marginal cost equal to marginal revenue for the monopolist. Now I'm going to set this up sort of generally, and then we'll plug in our values, and look at it going back to that same numerical example that we saw with the competitive market. So let me just make this a little bit bigger here. So okay, so we have a basic demand curve like we had before. P is equal to A minus BQ, and then marginal cost is just C. So just to restate the monopolist problem, they're going to pick Q and P to maximize their profits. That's all. That's all that says. And the optimal choice of Q, the monopolist quantity, is going to be found when the monopolist has marginal revenue equaling marginal cost. Classic profit maximization rule there. All right. So here's what we're doing mathematically. So first off, we set up total revenue for the monopolist. Total revenue from the monopolist is just P times Q. And we know that P is defined by the demand function, A minus BQ. And so we just take A minus BQ and we multiply it by Q. All right. So again, P times Q is just the demand curve times quantity. And so when you do that, you get AQ minus BQ squared. Sort of basic math there. So again, just took to find total revenue, we just took the demand function, which is P equals A minus BQ. We multiplied it by Q, and we got AQ minus BQ squared. Now, we're going to get marginal revenue here. We're going to derive marginal revenue, and to do so, we would just take the derivative of total revenue with respect to Q. Now, obviously, since we don't require calculus for this particular version of intermediate micro, I would always give you the marginal revenue functions. But if we did derive marginal revenue the sort of mathematical way, then it's just the derivative of the total revenue function with respect to Q. And so when we take the derivative, we get A minus 2BQ. So that's marginal revenue. And then we just set that equal to marginal cost, MR equals MC, and solve for QM. And then we get this sort of really interesting sort of outcome, which is that the profit maximizing quantity for the monopolist is going to be defined by A minus C. Now, what is that? What is A minus C? Well, A is, of course, the intercept of the demand curve, and C is marginal cost. So you can see that how much the firm produces is the numerator is the intercept of the demand curve and the marginal cost of the firm. So basically, the market itself, and the cost structure of the firm. And then you'll notice here that we have over 2b. B is the slope of the demand curve. So the intercept of the demand curve and the slope of the demand curve show up on both the numerator and the denominator of the profit maximizing quantity decision for the monopolist, as does cost. So you actually can just see this generally, like if the demand curve is hits higher up on the vertical intercept, then quantity is going to rise. If costs go up, then quantity is going to decline. If the slope of the demand curve grows, then quantity declines. If the slope of the demand curve declines, then quantity increases. So we can already see like how the different aspects of the market actually end up translating into different decisions for the firm. And I just think that that's sort of interesting as a way um, to sort of consider the math here. The math kind of gives us this nice insight into um, the sort of underlying structural um, decision making by the firm. Now, if we just take this logic and we apply it to the specific numerical example that we saw before, um, this is what it looks like. So again, now with this particular demand function, 100 minus 2q, same demand function as before, same marginal cost as before. So we're just replicating the same market conditions and cost structures. And so total revenue for the monopolist. Now, you'll notice here, right off the bat, we get a different outcome. So you'll notice the marginal revenue here for the monopolist is again a function of Q, whereas before for the competitive firm we just set marginal revenue equal to market price. It was static. Here we can see that marginal revenue ends up being a function of quantity, and we got this marginal revenue by first locating total revenue, which is just P times Q. So again, we just, in lieu of P, we put in the demand curve. And so 100 minus 2Q times Q, and we get 100Q minus 2Q squared. Take the derivative of that with respect to Q, and you get marginal revenue. So 100 minus 4Q. So we have marginal revenue. We know what marginal cost is. It's just 20. So the monopolist sets marginal revenue equal to marginal cost. So 100 minus 4Q. And we go ahead and put the subscript M here because we know when we solve this, it's going to give us the profit maximizing quantity for the monopolist. So 100 minus 4QM equal to 20. We do the math here and we get Q of M is equal to 20. That means that the profit maximizing quantity for the monopolist is going to be 20 units. You might remember that in the competitive market outcome, that value was 40 units. So we can already see that the monopolist considerably reduces the amount of the product that gets produced in this particular market. And so now all that's left is for the monopolist to find the profit maximizing price. Again, the easiest way to think about the profit maximizing price is that it's going to be the maximum willingness to pay that consumers have for that level of the product. Of course, maximum willingness to pay is defined by the demand curve. So if we plug in the profit maximizing quantity into the demand curve and solve for P, we get the profit maximizing price. And so if you plug in 20 into the demand curve and solve for price, we get that the profit maximizing price for the monopolist is $60. And so you can see the outcome is very different than the competitive market, where the competitive market produced 40 units. The monopolist produces only 20. And in the competitive market, the price was $20, whereas in the monopolist market, it's considerably higher at $60. You also notice, of course, that the monopolist charges a price which is much greater than their marginal cost. And again, that's where that sort of economic inefficiency comes from. If we look at the graphical outcome here, the classic sort of graphical outcome, we're interested in, of course, consumer surplus. You'll now notice that we have producer surplus. The monopolist is able to generate producer surplus, and we also have this deadweight loss, which is shown up here as well. And so when you do the calculations here, we get consumer surplus is now 400. You'll remember it was 1600 before, and producer surplus is now 800. You'll remember that it was 0 before. And so consumers lose $1,200 worth of consumer surplus. Producers gain about $800 worth of producer surplus. If we add those two up, we can see that total economic surplus is going to be 1,200. Again, comparing this to the competitive outcome where total economic surplus was 1,600, we can see that the market overall is less efficient because there's less surplus value being generated from it. And then when we calculate the deadweight loss, which again is just going to be this triangle here, you'll notice that this triangle is formed by the outcome, the competitive outcome. And so when we calculate dead weight loss over here, that's how we get these numbers. And so when we do the dead weight loss outcome here, we get $400. Now, what you'll notice is that previously under the competitive outcome, we had total economic surplus of $1,600, and now it's only $1,200. And you'll notice that we have $400 in dead weight loss. So the difference between total economic surplus under the competitive outcome and under the monopolist is exactly equal to that dead weight loss that was generated. Now, you may ask yourself, well, consumers were at $1,600 in terms of their consumer surplus. Now they're at 400, so they lost $1,200. Why is dead weight loss only 400? And that's of course because producers gained 800. And in the context of total economic surplus, we're not concerned about any one side of the market. We're concerned about the outcome of the market, sort of the raw economics of the scenario. And so here we can see that consumers are much worse off, producers are much better off, but more importantly, the market is worse off than it was under the competitive outcome. Okay, and then the last market structure that we're going to discuss is the duopoly, which again is a form or a type of an oligopoly. Now, again, the math is what distinguishes it here beyond the definition. So now, what is a Cournot duopoly? A Cournot duopoly is a duopoly where the firms compete over quantity. Now, the reason why that's a particular type of duopoly is that when economists started thinking about this sort of idea of, well, what if there were exactly two firms in a market? What would that sort of logically create? And so there were different types of structures that were considered, Cournot being one of them, another one being Bertrand oligopoly or duopoly, and another one being referred to as Stackelberg. Now, Bertrand considered pricing competition. So imagine you had two firms who competed over prices. And the interesting thing about Bertrand competition is that the outcome is the firms end up setting prices equal to marginal cost. And so Bertrand duopoly would actually end up having the firms charge prices equivalent to their marginal cost, which if you're paying attention, that would imply that the price in the duopoly ends up being equivalent to the price in a competitive market. And so in that sense, the firms didn't have any sort of market power because they competed with each other over prices all the way down to marginal cost pricing. Basically, there was always an incentive to undercut your opponent if you were competing over prices, and so the prices fall all the way down to marginal cost. We'll talk a little bit more about Bertrand later. Another type of duopoly would be what we call Stackelberg. And in Stackelberg, we have what we call a leader follower structure. So one firm chooses a production level first, and then another firm, seeing the choice of the first firm, chooses their production. So the leader follower structure, again, we're definitely going to talk about that a little bit later. In the Cournot setup, the decisions are made simultaneously to each other. So firm one and firm two make their decisions simultaneously. They don't have the benefit of seeing the behavior of the other firm before they make their particular decision. And although it's interesting because when you actually study the Stackelberg model, being a leader is much more profitable than being a follower. And so it actually is better for firms to be the first to make a quantity decision as opposed to the firms that respond to that quantity decision. But again, we're discussing Cournot, simultaneous decisions. Firms are picking what we're going to ultimately refer to as the best response. And so, what I mean by that is that in the um, Cournot, the duopoly profit maximization. So you'll notice here we have QI again because we have more than one firm, two, but more than one. And you'll notice here I have PD, that just stands for the duopoly price, just so we can distinguish it between the other two types of prices. And then here's the important part. You'll notice that QI is a function of Q not I. The negative I here just means not I. So firm one, their production is a function of firm two, and firm two's production is a function of firm one's. You sort of get the idea here. And then we have the classic cost structure for the individual firm. So the choice of the firm here in terms of the profit maximizing choice, the optimal quantity, is going to be a function of what they believe the other firm is going to do. Now, we make some other assumptions under the Cournot model. One of the assumptions that we make under the Cournot model is that firms have information. So firms know basically the strategies of the other uh, firms as well. The other assumption that we're going to make is that the duopolist here is a price taker. In other words, the choice that the firm makes is how much to produce, and then how much each firm chooses to produce is going to factor into what the market price is. Nobody's choosing market price directly. Market price is going to be a function of how much is produced in the market across the two firms. And so here we have a similar scenario that we had in the monopolist. So the duopoly price is going to be equal to marginal revenue for the firms, but that's going to be a function of how much the firms produce. So it's sort of similar to the monopolist outcome here, where marginal revenue was a function of quantity. Here it's really the same thing. It's just that quantity here is Q1 plus Q2. And then what that means is that the duopoly price ends up falling between marginal cost and the monopoly price, or more specifically, the competitive market price, which equals marginal cost. So duopoly falls in between them. So it's not quite as expensive as what would happen under the monopolist, but it is also more expensive than what would happen under the competitive outcome. And then for the quantities, it's the same story. The duopoly quantity falls directly in the middle. Not, I shouldn't say directly in the middle. It just falls in between the competitive outcome and the monopolist outcome. Okay, so here we say firms choose optimal production with respect to market demand and their best response to the other firms, which is respect to market demand and each firm's cost structure. Now, that's a little weird sounding. It looks like there's a little bit too many words there. The basic idea here is that the market demand and the cost structure of a firm is going to generate a best response. But then, because the firms are thinking optimally and because the firm knows the best response of the other firm, they're going to incorporate that best response of the other firm into their best response. And so, what you get is that each firm has a best response, which is a function of the other firm's best response. And the outcome of the duopoly is going to be both firms playing, or, so in a game theoretic way, we would say playing their optimal production. In this case, we can think choosing their optimal production, where their optimal production is going to be a function of what the optimal production is for the other firm. So the best response to the best response. And again, that's why it has a very game theoretic feel to it. So let's go back to the math, because again, the math actually I think clarifies the points that I'm trying to make, because it can be a little confusing. Your best response of a best response, what do we mean by that? And so the easiest way very often is to look at the math. Um, So going down here to the bottom, the math here looks like kind of scary. I'm going to go ahead and sort of spoiler alert you there, but I'm going to try to make it very easy, and basically turn this exercise into sort of a plug and chug. So I'm actually going to derive the best response functions generally, and then show you how we can then just plug numbers in and solve for the optimal outcome. Okay, so again, as we've had before, we have the same demand function, A minus BQ, marginal cost C, to keep things general. We're going to rewrite the demand function, though, as Q1 plus Q2 because we have the duopoly. So instead of big Q, Q1 plus Q2, that just means that big Q equals Q1 plus Q2. That's going to matter a little bit later. But this is really the main distinguishing feature here that we've not seen before is Q1 plus Q2. Now, again, going back to what we were saying before about the optimal response being a function of the optimal response of the other firm. So when we derive marginal revenue from total revenue, so when you calculate total revenue here, again, you take the full demand function. Here I've taken B and distributed it through already. We're going to take the demand function, we're going to multiply it by Q1, and that gives us, particular total revenue, and then we can derive marginal revenue. Again, here, this is marginal revenue for firm one, so it's just going to be the derivative of the total revenue function with respect to Q1. And so when we do the math, we get A minus 2BQ1 minus BQ2. So we have marginal revenue, we have marginal cost, which is just C. So we set marginal revenue equal to marginal cost, which we do right here. So A minus 2BQ1 minus BQ2 set equal to C. And then we're just going to solve for Q1. Now, notice what we've done here is we've set marginal revenue equal to marginal cost. So this is a profit maximizing best response function. But what we have to keep in mind is that when we calculate, or in this case, rearrange, because that's all we're really doing here, when we rearrange the marginal revenue equaling marginal cost condition to get the best response function, you'll notice that the best response function is a function in part of the other firm's response. So if we take this marginal revenue equaling marginal cost condition and we rearrange it, specifically solving for Q1, what we would get is Q1 best response is equal to A minus C minus BQ2 all over 2B. Now, this is a general result, meaning that we should be able to apply this result to any duopoly with a known marginal cost C, and basic demand curve of this particular structure. So this would actually work for other examples of the duopoly, again, where the demand is of the form A minus BQ and the marginal cost is of the form C. That this would work for any situation that would be similar. If the demand curve is more complicated, or if marginal cost is more complicated, then we wouldn't necessarily want to rely on these simple best response functions. So these provide us the best response functions. And now what we're going to do is we're going to take these best response functions, and similar to the way that we did for the monopolist, we're going to then go back to our example that we've been using for this lecture, the demand curve and the marginal cost value, and then we're going to plug those numbers in, and then we still have one more additional step, which I'll explain. So let me go over here to this math. So as you can see here, we're focused here. The demand curve is 100 minus 2Q, just as we had before. Marginal cost is 20, just as we had before. Now, it's important to point out here that both firms have marginal cost of 20 here. You'll notice over here, the way that I wrote it is that marginal cost for firm one and marginal cost for firm two are equal to C. So both firms pay marginal cost of $20. Um, if we plug the numbers in to the best response functions that I derived before, so that's just these down here. Oh, by the way, one thing I didn't mention that I should have mentioned is that because the firms are equivalent here, and by equivalent, I mean they have the same marginal cost, then they're going to have the same best response functions. So that's why over here if you look at these best response functions, I say by symmetry because we know firm one and firm two have the same marginal cost um, structure, then we're able to write it this particular way. They actually don't have to have the same marginal cost for these to be um, the same best response functions. The C's actually could be different. So, like marginal cost for firm one could be 10, marginal cost for firm two could be 20, and we could still use those best response functions. Now, if the marginal costs were of different forms, like one was, like C plus DQ or C plus DQ squared or something like that, then we wouldn't be able to use these simple best response functions. But when C is a constant, that when marginal cost is just a constant, even if those constants are different across the two firms, we can actually rely upon these best response functions um, generally speaking, and so we could use them for multiple examples here. These two best response functions, um, right there. So that's what we do here. We just take those best response functions here, and we plug in the values. So 100 for A, 20 for C, and then 2 for B. And we do a little math here. And what we get is this best response function um, for firm one and for firm two, which are going to be the same. I think I erased um, the best response function for firm one. So let me just go ahead and write that. So when you do the math here, all right. So again, we just simply plug in the values into these best response functions to get these two very simple best response functions for firm one and firm two. So 20 minus Q2 over 2 for firm one and 20 minus Q1 over 2 for firm two. Now what we're going to do is we're going to plug Q2 best response into firm one's best response function and then solve for Q1. And that's going to actually give us Q1 star here. And so Q1 star is equal to, so you notice this is just 20 minus, and then for Q1, or sorry, Q2, we've plugged in Q2's best response. So 20 minus Q1 star over 2, because that's firm two's best response, and then divided by 2. Um, and then solve for Q1 star here. And when you go through the math and you solve for Q1 star, what we get is that the optimal quantity for firm one, which is a response to the optimal quantity for firm two, is going to be 16.67. And then, of course, because everything is the same for firm two, they have the same marginal cost, then their optimal quantity is also going to be 16.67. And then if we take this outcome and we compare it to the competitive outcome and then also ultimately the monopoly outcome, which we're going to do in just a moment, we're just going to add up these two quantities to get the market quantity. So Q1 plus Q2 ends up being big Q. But again, let me just, again, this may be a lot for you if you've never done this before, and most people have not done this before. All we've done here is we've taken the simple best response functions that we got over here to the left. And all we did here to get these best response functions to the left is we did the profit maximizing rule, marginal revenue equaling marginal cost. The trick was, though, that the best responses ended up being functions of the other firm. And the other firm also has the best response function. So, in order to actually calculate the optimal quantities for the two firms, what we have to do is we have to take the best response functions, we have to plug in the values from the market demand curve and the marginal cost, which we did here. We did a little bit of math, and again, we got the simple 20 minus Q2 over 2 and 20 minus Q1 over 2. And then to actually solve for the optimal values of Q1 and Q2, we plugged in the best response functions into each other and solved for the variable in question. So to solve for the optimal choice for firm one, we just plug in firm two's best response function into firm one's best response function, specifically for Q2. We get 16.67 for the two firms. And so, like I said before, we're just going to add that up. And so I did some rounding here to make our life a little bit easier. And so 16.67 plus 16.67 is going to be a little bit over 33, but I rounded down just to make our life a little bit simpler. And so with a quantity of 33 across the two firms, we just plug 33 back into the demand function that we have over here. Which allows us to compute the duopoly price. And so we plug 33 into the demand function, we get 34. And so the duopoly outcome is a quantity of 33 and a price of 34. And then when we go through and we compute consumer surplus and producer surplus, you'll notice that consumers are better off than they were under the monopolists, but not quite as good off as they were under a competitive market. The producer are better off than they were under the competitive market, but not quite as good as they were under the monopolist market. Now, understand that the firms are going to split this producer surplus. When you calculate total economic surplus, you see it's 1551, which is less than the competitive market. So that means we have deadweight loss. So you'll notice that consumers pay a little bit more under the duopoly than they would under the competitive market, where they pay $20. Here they're paying 33. I'm sorry, paying $34. They're also not getting as many units of the product. They were getting 40 units before under the competitive market. Now they're only getting 33. And so the duopoly is not as bad for consumers as the monopoly. Um, it's not as good for producers, of course. And then, as sort of the market as a whole, it's a little bit worse than the competitive outcome and considerably better than the monopolist outcome. And so, just to kind of put that into review, so in the competitive market, consumers paid $20. They got 40 units, and there was zero deadweight loss. For the monopolist, consumers paid $60. They got 20 units, and they had $400 in deadweight loss. And then for the duopoly, they paid $34 for the good. They got 33 units, and there was $49 in deadweight loss. So you can see that the math aligns with the sort of philosophy of the different markets. The monopolist is the worst market in terms of the economic efficiency. The competitive market is the best, and then the oligopoly, the duopoly, falls somewhere in between. And so this is one of the reasons why I love economics, because the math really does tell the story.